Now in this very first lecture of this section, we are going to learn what is a tree. So by definition, a tree is a nonlinear data structure with having hierarchical relationships between its elements without having any cycle. Basically, it's reversed form of a real-life tree. So what does it mean? So to understand this definition, let's look at a real-life example. As other data structures, we are using tree data structures in our daily life. So let's say we are in a cafe and we want to order a drink in this case. Now when we open the drinks page on the menu, we can easily see that in this case we have two types of drinks. So here we have hot drinks and cold drinks. So for example, if we want to order hot drinks, we can easily see that here also we have two types of hot drinks. So we have tea and coffee in this case. Now on the other hand, if I want to order cold drinks, here also we have two types of cold drinks, non-alcoholic drinks and alcoholic drinks. Now if I go one step further and want to order, for example, tea, in this case, here also we have two types of tea. So we can order black tea or green tea in this case. Now if I want to order coffee, in the menu we can see that we have three types of coffee in this case. So we have Americano, latte and cappuccino. Now if I continue to the cold drinks, in this case we can see that for non-alcoholic drinks over here, we have also three types. So we have cola, Fanta and soda. And for alcoholic drinks, we have two types. So in our menu, we have wine and beer. Now you can see that for each type of note over here, we have specific types under it. So here we can easily see that drinks in cafe's menu have been ordered in a nice hierarchy, which makes it easier for customers to choose. So here they might not be aware that they are using tree data structure. But this way of organizing data in cafe menu makes it easier for customers and owners as well. Now in the world of data structure, this is called tree data structure. So as you can see, without being aware of tree data structure, we are using it in our daily lives. So the diagram that we see over here represent a typical tree data structure in computer science. So let's see what are the common properties and observations we can get from this above diagram over here. Now the first property is that this diagram is used to represent data in hierarchical form. It means that every time when we go one step down, it becomes more specialized form of its parent. For example, if we are coming from hot drinks one step down, we can see that here we have tea, which is the type of hot drink, and we have coffee over here. So here tea and coffee is specific type of hot drinks over here. Now similarly, if we go one step further, for example, from non-alcoholic drinks, we can see that soda, for example, is a specific type of non-alcoholic drinks. So this means that every time when we go one step further, we are doing a specialization. In other words, we are maintaining a hierarchical form. So we have identified that the first property is that this diagram over here represents data in hierarchical form. Now let's continue to the next property, which is every node has two components, which are data and a reference to its subcategory. So let's see what does it mean. So let's say if we consider type drink as a node, so if we consider these drinks as a node, we can see that it has in this case a hot drink and a cold drink. So in this case, in this node over here, drinks is the data, and from here, from this node, we have a links to the hot drinks and cold drinks over here, which means that in this node, we are storing the address of subcategories, in this case, address of cold and hot drinks, and in this node, we have the value of drinks over here, which is the data of this node over here. So similarly, if we examine the cold drinks, we see that it stores cold as a data and it has references to alcoholic drinks and non-alcoholic drinks. So this means that it is storing the physical location of these subcategory nodes over here to itself. So in this case, it has two components, so the data and links to its subcategory over here. Now let's see the third property of this diagram over here. The third property is that at the top, we have a base category, and then we have subcategories under this base category over here. So in case of typical tree, we can have as many as subcategories under one category, and there is not any limit with this. So these are the properties that can be driven from this diagram over here. Now let's see tree data structure properties. And it's not a surprise that we have the same properties for the tree data structure over here. Now this is the typical tree in computer science, and now let's see the properties of this tree over here. Now the first property of this tree is that it's used to represent a data in hierarchical form. So this is same as the first property of diagram that we discussed. So the next property is that in every node we have two components, which are data and references to subnodes, which is same as the second property of the diagram that we have discussed. So here also you can easily see that, for example, N1, this is the data of the first node over here, and it has references to the N2 and N3 over here. So this means that it is storing the physical location of N2 and N3 over here, and it continues like this until end. And finally, last property of tree data structure is that it has root, and under root node we have subnodes. And this is similar to the last property of diagram that we discussed. So here we have seen the properties of tree data structure, and we see that it resembles a real tree data model from real life. Now let's quickly see how these properties fit in this tree over here. So here in this tree data structure, we can easily see that we have a root node of N1, and then we have subsequent nodes over here. So if we closely examine this tree, we can see that the data that is represented over here is in hierarchical order. So we have at the top N1, then we have N2 and N3, and these nodes also have subsequent nodes N4 and N5 and N6, and N4 nodes over here has also subsequent nodes which are N7 and N8 over here. So this shows that the data is in hierarchical order. Now the first property is satisfied from these three over here. Then we can easily see that every node has two components in this case. One is the data, and another property is that it has references to subsequent nodes over here. So we can easily see from, for example, from this node that the data is N2 and it has references to N4 and N5 in this case over here. So this node has two components, so this property of tree satisfies the property that we mentioned over here. Now let's continue to the last property. We can easily see that N1 is a root node and it is the first node in the tree. And then it has subsequent nodes under it, which are N2 and N3. So we can easily see that the third property, which says that base category and subcategories under it, also satisfied in this case. So this is all for this lecture. So in this lecture, we have learned what's the tree data structure and what are the properties of it. And we have learned that we are using tree data structures during our daily lives, even without being aware of it. So hopefully, with this lecture, you have understood what is a tree data structure. Now in the next lecture, we are going to learn why do we need a tree data structure. So see you in the next lecture.